Thank you very much. Well, just a wee bit difficult following Eric and Bill and Ram and Janet and all the energy that's gone before. But let me start right away by saying my view of this is a little different from each of the others in the sense that I've been working as Chief Scientific Advisor to the British government for 7.5 years and was heavily involved in the negotiations that we've now been discussing. I'm going to start then with a statement that I believe today that you can govern without science, but you cannot govern well without science. And we can take a large number of examples of this, but I'm going to select an example that I hope will appeal to this audience. Back in December 2004, December 26th to be precise, the Sumatran Trench gave way off the Indonesian coast. A net number of people lost in that event was around 235,000. And the people of Banda Aceh, shown here, had no chance at all. That tsunami was upon them before they knew what was happening. But that was simply not true of most of the other people who were caught up in that tsunami, the people of Sri Lanka, the people of India, and even the people of Kenya, where the tsunami arrived many hours later. Quite simply, there was no early warning system in the Indian Ocean. I went into the United Nations on January the 3rd that year, having formulated a report and being told by my Prime Minister to take it into the United Nations. And what I did was simply ask in the United Nations HCR, the humanitarians group that deals with disaster, what risk analysis had been done around the understanding of tsunamis on the planet? And the answer was effectively none. In fact, I was told that tsunamis are meant to happen, believe it or not, in the Pacific Ocean. And so it was totally unexpected that a tsunami would occur in the Indian Ocean, so how could we have anticipated this? Now, of course, the seismologists who understand about plate tectonics back in 1979 produced a map of the world showing several straight lines of zero movement between plates, where they predicted that movement was bound to happen and would be leading to very significant effects. The first of these they predicted would happen was off the Peruvian coast. Remember, this was 79, and it happened in the mid-80s. The second of these they predicted was this particular trench, and it happened. And of course, right now, we are putting an early warning system into the Indian Ocean. Just as we put an early warning system into the Pacific Ocean after the event. I've got a few colleagues, one from Oxford, one from California, who went into Sri Lanka, Indonesia, and India, believe it or not, in July 2004, to say you need an early warning system. Cost of early warning system estimated at $30 million to install, and they got absolutely no shrift whatsoever. They couldn't actually reach the system high enough to get the scientific advice into a point where a decision could have been made. And I think you get the gist of it. If we understand, as we do, with enormous degrees of certainty, given the complexity of these systems, if we understand our planetary system as well as you people are developing that understanding, it's critical that we get that understanding through to the political system. And we're not beginning to manage it. We're not even close. Now the United Nations HCR has a man I know very well leading it, and he is introducing risk analysis. There isn't the funds available, though, to develop a proper scientific office there. So we also need to re-examine, and this will be the theme of what I'm going to say, how we make global decisions as we move forward in time. I estimate that 170,000 lives would have been saved with an early warning system in place. So what we have here is a very specific example of the lack of the knowledge base getting through to the decision-making process. Now, I just want to pick up on what has been said about our population, but I'm going to place it in a very different context. Yes, we're going to have to plan for 9 billion people by mid-century, but let's just read this in terms of the successes that we've brought around the planet in the 20th century. We entered that century with a population, as you've seen, of about 1.5 billion people. Life expectancy around the world was about 40 to 45. And by the end of the century, through our developments in civil engineering, sanitized water being the greatest of these, through our developments in science, engineering, medicine, agriculture, technology, and the spread of these around the world through our institutions, life expectancy around the planet has increased, as you see here, to 65. India's now over 65, China's now over 70, and the rest of the world is 80 or above, apart from the one continent I put in the middle of this map, which is Africa. But the result of this, because of that population dynamics you heard about right at the beginning, and let me phrase the population dynamics in my own way, if I may, a little bit of repeat. The population dynamics that is general applies, for example, to Britain in the Middle Ages, where female fecundity was about 7, and on average 2 children lived to maturity. And then we get clean water through civil engineering, and up goes the survival rate, and all 7 or 8 children live to maturity. Women get caught out for 2 generations, so you have a second generation where again the average is 7 children per woman, and then the third generation comes along and it crashes down to 2. It takes women at the moment 2 generations to catch on what is happening, and I'm suggesting, and sticking my neck out here, that female education and female empowerment and the availability of contraceptives are the key factors in population control. Yes, I do understand that blokes are involved, but I think it's absolutely key to our understanding that it's women who make the decisions. And so when I also then tell you, yes, South America's undergone this transformation. South America, female fecundity about 6 just 30 years ago is now 2.2 as the continent as a whole. I think we're talking about a Catholic country, aren't we, or Catholic countries. The lowest female fecundity in the world, now Italy, 1.2. I think, again, we might be talking about a Catholic country. What I'm suggesting is that women know something. There's the forgotten continent in the middle of my map of the world here, my own continent. I'm an African. And there, life expectancy is in reverse at the moment. In Zambia, it's now 41.2 and going down. In Zimbabwe, next door, it's about 43. We're not sure because the figures are not available there. Sub-Saharan Africa as a whole, we're talking about 40, 45. So we've got a continent riven by malaria, riven by TB, and now also riven by HIV and AIDS, in addition to problems of food supply, desertification, and so on. So one of the issues I do want to raise before I move on to the more general issues is, what on earth is happening in Africa? Why is that the forgotten continent? And I found when I first came into government that there's something remarkable in the international development community. I think this is moving now, but there is actually an anti-science attitude towards development. That attitude that I'm describing means that when I first stood on a platform with about this number of international development people, workers involved, I was booed as I stepped up to the platform. I've never been booed as I stepped up to a platform before. The mere fact that I was a scientist, chief scientific advisor to the British government. And why? Because it was seen to be elitist. You're the sort of people who are trying to see universities established in that continent and the focus will be on delivering PhDs, and that would be irrelevant to the development of the continent. And I went into the World Bank and found that this view is deeply embedded there. Botswana is the country which has gone into reverse against the other sub-Saharan countries in terms of GDP growth. What the citizens of Botswana did through their cabinet and Prime Minister, Seretse Khama, started this, was to actually turn down foreign aid. And their GDP growth went up in direct contrast to the rate at which they turned down foreign aid. Foreign aid was tied to particular outcomes. Each little basket of foreign aid, you were required to do a certain amount of things, and then photographers came in a year later to photograph what you'd done. And what this meant was that the country couldn't plan large-scale infrastructure, couldn't plan what was actually needed from the country's point of view. They were always delivering what these aid presenters were delivering. I'm chief scientist now to another government, the government of Rwanda. Lake Kivu's methane is going to transform the country's energy capabilities. There we have also transformed the policy. The army barracks is now the Kigali Institute of Science and Technology. We are now beginning to transform the skills base of that country. And we turn to aid people and say, give it to us in a basket so that we can spend it all together on large-scale infrastructure. I was able to sign an agreement in my last act in government with the government of Rwanda for £50 million a year, guaranteed for the next 10 years, and all we will do is audit what you've done with the money. And they are putting up infrastructure, roads, universities, schools, female empowerment, absolutely key. And if I tell you, look at a table of women in parliament, and you will find Rwanda at the top of the table. The elections last year produced 65% of members of parliament women. The Minister of Justice is a woman, the Foreign Minister is a woman, half of the cabinet are women. So what we have is a country where the empowerment of women is actually happening and is transforming the country as it goes forward. There are ways of handling these problems, and the ways involve understanding the importance of the skills base in our own development, and therefore the need for capacity building is absolutely key. So I'm not against aid. What I'm against is aid tied to small outcomes on a short term, which in countries where there is a shortage of skills, the civil service is very thin, the civil service spend all their time dealing with the aid agencies and none of their time responding to the democratic needs of their country. It actually leads to weak governance because you're not responding to the democratic electoral demands. So when we look at Africa, what you can do, for example, is compare it with the Indian development. In India, at the time of independence in 1947, Jawaharlal Nehru asked the four great powers, as they were then described, each to give a present for independence to India. He wanted one Indian Institute of Technology from each country, and that's what they did. They each gave one. And those Indian Institutes of Technology, I would suggest, have transformed the landscape of India. There's a tremendous demand from Indian young people to get into them. The rate of success is 1 in 800. And the other 799 go into universities. They all have enormous aspirations because of the high ratings of the Indian Institutes of Technology. I'd like to see 5 African Institutes of Science and Technology funded at a generous rate. I'd like to see each with $1 billion endowment so that we can really pull back the diaspora. Africa is losing 100,000 skilled people a year to the north. We have to reverse that by creating a magnet in the center of Africa. Let me leave my favorite theme now and just move on. You've seen this already. We have to plan for 9 billion people by mid-century. Let's take that median graph and begin to prepare the planet for these 9 billion people now. And if I then move on quickly to what is now being called the King Carousel. This carousel represents the key challenges that we face as we go forward. We take population as the driver. It's a given, but it doesn't mean there's nothing we can do. Let's keep pushing on female education and empowerment. Let's remember, by the way, that China, through its policies, has probably removed already today 350 million from the global population. So there are things that can be done, but the real issue is let's accept 9 billion is what we plan for, and these are the challenges. And we can look at any one of these carousels and see the sort of problems that we have. Take food production. Because of the improvement in living standards in China, India, all those countries where well-being is increasing with time, we see a greater demand for meat, and this means a greater demand for crop production. So as we move forward, we see that even by 2030, when the global population will pass 8 billion, we will need 50% more crop production than we have achieved today. We need another green revolution to manage the demands of this growing population with its demands for improved well-being. We need another green revolution or two. The green revolutions in Asia transformed the crop production per hectare by a factor of roughly 7 in India and China. We need another large factor increase. And as we move forward, we therefore need to use the best science available to us. We have it. Biotechnology offers it. We have an extremely clever capability. So, for example, that big hike we saw in a previous graph on rice prices, also in grain prices that occurred between April and July last year, that enormous hike hammered poor people. For us, it's marginal. A threefold increase in rice prices, a threefold increase in grain prices. When you're living at the edge at 50 cents a day and you're suffering malnutrition, that knocks you over the edge. So we saw a very significant increase in the number of people suffering malnutrition as a result of those price increases. There were two major aspects to the price increases. One aspect was the American policy on biofuels. Converting food product grain into biofuels created a shortage. Second generation biofuels I'm all in favor of. First generation, let's think again. But the second part of that was an excessive amount of early rainfall in areas where there were heavy rice crops in the paddy fields. Now, what happens to rice is that you plant it where there's likely to be a lot of water, but actually, in the early development of the plant, it can only take flooding for about 2 days and then it dies. And that's what happened over a larger area than usual last year. That was an unnecessary factor. I say that because in 1995, a wild rice plant was discovered that is flood resistant. You have a flood, and there are a few plants still growing, not a particularly edible rice. You can eat it, but it's not marketable. And there it is. There's a rice plant that knows how to take flooding, and you can flood it for 3 weeks. From seed, it'll grow right through the water, and it'll produce a crop. Simple to then discover which genes in that wild rice plant were producing that flood resistance. That's been done using genetic markers. You can then snip the genes into marketable rice and bingo. You've got a flood-resistant marketable rice. Has it been used? No. Why not? Principally because the European Union has produced a very negative approach to GM crops, and this has been picked up in Africa and in Asia as meaning if it's not good enough for them, it can't be good enough for us. This is extremely poor science getting into policy making. The European Union has no chief scientific advisor advising the European Union on its policy. So we have in the European Union the world's greatest experts on determining the amount of GM crop in an otherwise standard crop. The world's experts. Why? Because we sample every crop coming into the European Union. And the phrase used is to see if it's contaminated. There's no sign of any human being ever suffering from a GM crop. And I'm going to claim to you that I can give you evidence of hundreds of thousands, if not millions of people suffering from malnutrition last year as a result of a negative attitude. So our ability to talk to society and to politicians is what's at fault here. I'm not saying scientists are to blame. We have to generate a bridge and change this. Now, let me just quickly say, food production, I've chosen one part of the carousel, but let's remember these are totally interconnected. The United States felt that there was an energy security problem. What it meant was importing oil products from other countries because they had passed their own peak oil. And so let's convert grain to biofuels. Solving one problem, creating another one around the carousel. These are all interconnected problems. Food production, if we do this without more intensive farming and cleverer techniques, we're going to use more and more of the land mass to produce food, and there'll be less and less of it available for that biodiversity part of this ring. So what I am saying is that our ecosystem services, a critical part of how we live on this planet, are at risk unless we start managing all of these together. We need to look at water resource. Let me give you an example there. State of Victoria in Australia has had 8 years of successive drought. Climate scientists are saying, well, we predicted that. 8 years of successive drought has meant that the farmers are leaving the land. They have packed up their bags. But more than that, the state of Victoria is now building desalination plants at quite a rate. And as a matter of fact, by the end of this year, 30% of the water provided for the towns and cities like Melbourne and villages of the whole of the state of Victoria will come from desalination plants. Now you could say, Dave King should be happy, that's a technological solution. The desalination plants are all energy intensive. They're all using coal, all of them. They're burning coal because they've got lots of it. You burn coal, you produce carbon dioxide. Carbon dioxide causes jump over there, global warming. Global warming causes desertification in some parts of the world, including southern Australia, and you've created a negative feedback loop of the kind that you seriously ought not to do. So as we go around this carousel, I'm suggesting all of them are actually, in a complex way, interconnected. I'm then going to move on, since we've already seen from Eric's presentation the state of our minerals as we move forward in time. Let me just move on to conflict and terrorism for a moment. I made the statement in 2004 that global warming was a more serious threat to mankind even than terrorism. And it certainly got the attention not only of my Prime Minister but of the President of the United States. And for some time I was not allowed back in the White House with my Prime Minister. But the point here is that actually conflict and terrorism will emerge, I believe, in this century, in the latter part of this century, in a new form. We're going to see environmental migrants. There already are some. We're going to see environmental migrants become a large part of conflict occurring around the planet. The Indian government understands this. If you believe that that enormous fence going around the border of India and Bangladesh is to keep out robbers, think again. I believe that the Indian government is fully aware of the rate at which sea levels are rising, and that Bangladesh is a low-level country with hundreds of millions of people who will need to seek higher land as we approach mid-century. I also, by the way, don't believe that that wire fence is going to work. So I just think we need to think very carefully as we move forward in time about this carousel. We have had a very poor recent history. Let me make a statement that you might find surprising from a chief scientific advisor. I believe that the Iraq War was directed around the peak oil that the United States had been through. I do believe it's associated with security of supply to the United States of America of oil supplies. I was in the White House in the run-up to Iraq. I do believe that this was seen as an investment in securing energy futures for the United States, to see that there was a friendly government in place in Iraq. Stiglitz, the Nobel Prize winner for economics, estimates that Iraq cost $3 trillion to the United States. I'm not counting the cost to the United Kingdom. And if you then ask a question, if that was for energy security and you had a discussion around how best to use, not 3 trillion, let's just take a tenth of that. Take that sum of money, what would you do to secure the energy supply of the United States? I'm presuming you would suggest we decarbonize our economy. In other words, with that sort of sum of money, I believe a real investment could have been made to secure the energy future of the United States, and at a significantly lower cost than the attempt to secure the energy future that was made. This all suggests that we have the potential for placing wise people in positions of power. And that, of course, is the real question I want to ask. The United Nations is the body where decisions on these global issues have to be discussed. Surely, it shouldn't be feasible for any country to build desalination plants that use coal that exacerbate the very problem we're trying to deal with. This is also happening, of course, in the Middle East. Wherever you have desalination plants, blow me, you've got a lot of sun. Why aren't we using solar energy for all of those desalination plants? It's not beyond science and technology to drive these things to the marketplace. So what it requires, I'm afraid, is a form of global governance that we don't have. The United Nations was formed by a prescient President of the United States suggesting that the League of Nations was now finished. 2 world wars proved that, and what we needed was a United Nations, and that was formed. I'm suggesting the United Nations is no longer fit for purpose. It has been pushed into the background as we've moved forward in time. We need some visionary leaders, and I do suggest the United States and China have visionary leaders today, visionary leaders to stand up and say, let's re-examine how we make these global decisions to secure the future for those 9 billion people as we move forward in time. That, to me, is the big hope, getting Obama and Wen Jiabao, 2 of the most intelligent leaders in the world, on a platform saying, let's deal with these issues. We've seen quite a bit about climate change already, and I won't say too much. What I'm going to show you here is the set of curves that I have used with the British government. I've given lectures to the British government and about 40 governments around the world on climate change. This is the slide that tends to get it home. So basically, it's not just taking, as you've got in the bottom there, the last 420,000 years from paleoclimatology. So here I've got in, from the Fedorov et al. Paper, I've got the last 420,000 years with the temperature, oxygen 18 as the proxy, in blue, and the carbon dioxide in red, but going back 60 million years using ocean sediment data. So we got this wonderful agreement between 2 completely different sets of data, the ice cores and the ocean sediment. The ocean sediment without the same resolution, but never mind, we can go much further back in time. So just looking at the last 60 million years, you can say, well, where have we already got to in terms of the amount of carbon dioxide we've put in the atmosphere, that 387 it is now parts per million this year. Where have we got to in time going backwards? And the answer is roughly where that red line is, the vertical line. So we know that in terms of greenhouse gas content, there's some good news there. We've probably done plenty to switch off the biphasic oscillations in temperature represented by the glacial interglacial periods. So never mind about the next ice age. However, will we stop going up that curve? We've got enough carbon, naturally sequestered carbon in the form of coal, oil and gas, that if we burn it all, we can almost certainly get back up to that peak when there was virtually no ice left on the planet, when not only Greenland's ice had all melted, but Antarctica was a subtropical forest. Antarctica was a subtropical forest with large mammals on it, not many large mammals in other parts of the planet, particularly between the tropics, where it was exceedingly hot. So we know that that is the experiment we don't want to try out to test the models. And the question then is, have we got the sense and the sensibility and the political systems in play to stop us doing that? And that is, of course, the live issue that we're all keen to deal with. Now, I just want to say, as we move forward, we have a political necessity, and I'm expressing it in terms of these 4 bullet points for an international agreement. But let me pay tribute to the Intergovernmental Panel on Climate Change, like others have done, a quite strange scientific organization. Strange because scientists meet to challenge each other, to disagree with each other, to display their egos. And it's very unusual for a group of scientists to meet to provide a consensus on an issue. And that's what was required by the Intergovernmental Panel on Climate Change, and they've done it, and they've done it extremely well. What we also had was the United Nations Framework Convention on Climate Change, backing up what the IPCC was doing. 192 nations meeting in Kyoto, all signing up to the Kyoto Protocol, and then how many of them ratified? Well, of course, there were key countries that didn't ratify Kyoto. As a matter of fact, it was very easy for countries to ratify that had nothing to do as a result of ratifying. But what about countries like Russia that ratified? I know they ratified because I was the one that was sent by my Prime Minister to make them ratify. That was my toughest task ever, and over a beer I can tell you about it. Very happy to get on a plane with my skin still on my back, I can tell you. And the next day, the Moscow Times headline in big print was, "Brits declare war on Russia." And I had to go in and explain to Tony Blair that I didn't mean to. But essentially what I said was interpreted as a war on Russia because their economy so heavily depends on oil and gas. So what has the United Nations Framework Convention achieved over the years since Kyoto? I would say virtually nothing in terms of the real action to reduce carbon dioxide emissions. The European Union is the only part of the world that has implemented most aspects of the Kyoto Agreement and gone beyond it. I managed after that, the furore around my statement around climate change and terrorism, I did manage to persuade the British Prime Minister to put climate change at the top of the G8 agenda in 2005. We also decided to invite the heads of states of the +5 countries as they've now come to be known: India, China, Mexico, Brazil, and South Africa. And what that meant was that we were bringing together the key countries that were needed to reach an agreement so that we could go back into the 192 nations of the United Nations Framework Convention with leadership from the top countries. Unfortunately, George Bush was still in the presidency. We did manage to push that very hard, but there was this enormous frustration of writing an agreement and then it coming back from the United States with red lines through most of the meaningful sentences in these agreements. Now I'm afraid, as we move forward, not afraid, I'm delighted, the United States is fully engaged in the process. So in Bonn a few weeks ago, there we saw the American delegates pushing hard for a good agreement. China pushing hard for a good agreement. There's the consensus emerging that we would all want to see. China, by the way, doing as much as the European Union in reducing its own emissions. And so now what has emerged? 2 countries blocking the way. We've now got Japan and Canada trying to blow it apart. And so what happens is if one country starts saying, yes, let it happen, there are others that are going to try and prevent it. I'm afraid the political consensus and the political appetite for action is not there yet. We have quite a long way to go. So as we move forward, yes, in Britain we've now written it into law that by 2050 our emissions will be reduced by 80%. So coming to the level of why 80%, let me give you the rationale. Today we're emitting, I'm giving you carbon dioxide and not carbon. Most of the figures have been in carbon, but we globally are emitting 36 billion tons of carbon dioxide per annum. We need to be globally at 18 billion tons of carbon dioxide per annum if we are going to be on a pathway to stay anything close to a 2.5 degrees centigrade temperature rise or less. That's 50% down to 18 billion tons for the whole planet. We will be 9 billion people, divide 18 by 9 and you've got 2. We should all agree, nation by nation, and I have traveled around most countries in the world to talk to heads of states suggesting this, nation by nation, arrive in Copenhagen saying, I agree, my country by 2050 will be at 2 tons per person per annum. Then we will begin to manage it. If we have the hunger to do that, we will manage it. President Lula, I have to say, challenged me and we challenged him back, and he was one of those coming forward with a very clear proposal to move towards that 2 tons per person per annum. So if we can manage that, and by the way, that's what 80% reduction in Britain would mean, we would have achieved the 2 tons per person per annum. If we can, let's say we must, then we are going to manage the problem. Surely that is an equitable solution. We need to argue it in our own countries as an equitable solution. The argument that, for example, the United States, I mean, easier for Europe, we're at 11 tons per person per annum now. The United States is at 23 tons per person per annum. However, that means you've been putting up a legacy for the rest of the world. So there should be a greater responsibility. Let's take it all on board and see if we can reach an agreement. And these are the 4 elements of the agreement that must be reached in Copenhagen in the protocol. I'm not saying in December because I have a feeling that we may have to go into 2010 to make this work. It's not moving quickly enough now. The Waxman-Markey bill is a big step forward, but until the United States president is sure of what he can take to Copenhagen, this isn't going to happen. We need to agree a stabilization level. Can we agree to stay below 450 parts per million CO2 equivalent as an asymptote? If we agree that, then we can put national trajectories for each nation going through that 2 tons per person per annum level by mid-century as one way forward. Once we've agreed national targets, then we can price carbon dioxide, because with downward moving carbon dioxide levels, the price of carbon dioxide will be kept high, and we have a tradable commodity, and that locks the world into place on seeing that we are on these downward trajectories. I'm afraid a carbon tax is simply not on. If we introduce a carbon tax, What will stop a democratic system producing a party that doesn't say, we will come in and remove that obnoxious tax? Whereas once it's a tradable commodity, and in Europe, we already have 150 billion euros in the carbon dioxide market. There's too much money in it to let it collapse at this point. So we need carbon trading as a mechanism for making it happen, and then we need a process for dealing with developing countries. And this is a non-trivial sum of money we're talking about. These are the countries where the impact is going to be highest. Come back to Africa, temperature rises will be higher, and the financial capability of managing yet another stress on that continent is not there. So we need a flow of funds. Where would you establish that? The carbon trading. You create permits which are auctioned for the carbon trading, and now instead of reducing your taxes, which I think would be counterproductive, use that as a mechanism for dealing with the fourth bullet point. So all of these things are, I believe, politically doable if there's the appetite for action. Now, appetite for action, and this is my very last point, implies, I believe, a substantial paradigm shift. And the paradigm shift I'm referring to is, I think, no less than the shift that took place in the 1400s, 1500s in Europe, the Renaissance. I'm suggesting that since the Industrial Revolution, we have had very successfully driven economic growth through consumerism. The consumerism has developed into rampant consumerism, and the rampant consumerism form is not fit for purpose to manage this dwindling resource that the planet presents for its 9 billion population by mid-century. The paradigm shift, therefore, needs to take on board these challenges are now the biggest challenges our civilization has ever had to face up to. And what is required is slightly different from the Renaissance in the following sense. I don't believe that the people of the Renaissance, Leonardo, sat down and thought, enough of those awful Middle Ages, let's dig ourselves out of them and create a cultural revolution. It was not a conscious revolution that was taking place there. Now we do need a consciously driven paradigm shift or cultural revolution. And that's got to come from our understanding of the direction the planet is moving in and our ability to spread that message to other people around the world, exactly what the other speakers have been saying. Now, this is what I see as the set of drivers against the paradigm shift I'm talking about. First of all, national perceptions versus global priorities. We have developed a habit, and it's driven by our democratic systems, of thinking of our own country first, foremost, and even last. And so national perceptions of priorities actually block the ability to reach agreement on these global matters. The second is economism. I fear, and I have to say, I had these bullet points set out before the recent economic crisis. I fear for a world in which the Chicago School of Economists have completely taken over, in which the world in which economic growth is always continuously exponential forward in time, with some kind of doubling period that never changes. That world is all built on linear economics. There's not a scientist who would look at that and say, for goodness sake, where are your feedback terms? And it was massive feedback terms that suddenly produced the current fiscal crisis that we're in. So, and it'll be massive feedback terms, and here, for example, I think I don't agree with Stern's analysis. As we move forward in time, we have a potential for much bigger feedback loops on the economic system. If we move into environmental migration and much increased terrorism that can follow and global action, and by the way, if we move down that scenario, we would look back and see the Iraq war as the first of these disasters. If we go down that route, we are going to see an economic crisis of a kind that nobody is currently predicting. So that it's not built into any of these economic models. So I'm not sure that consumerism as such is something that is fit for purpose. I am also not sure that the Chicago School of Economics that has dominated the world economy since the 1950s is fit for purpose in the coming century. Nostalgic romanticism, I think, is something that would probably be better understood in Britain than anywhere else. I'm referring to those who are all for going backwards in time. Hair shirts and sandals is the sort of thing I'm getting at here. The future is going to be determined by our understanding of the science, and from our understanding of the science, managing the risks. We need science as we move forward to manage the risks. And it's going to be technology, and coupled with science, that will provide many of the solutions that we need. So let's forget the nostalgic romanticism. But that's quite a strong force that we need to struggle against. And then there's the scientific community itself. I'm going to make a statement that broadcast beyond this community may well be misunderstood. I don't think there should be a son of CERN. CERN is a magnificent scientific effort. It's costing billions of euros to put up, and it has drawn into it some of the world's best brains. Now, I'm very excited about whether or not there's a Higgs boson. And at the same time, I'm a little concerned about the fact that the scientific effort going into finding alternative energy sources, low-carbon energy sources as we move forward, that is micro-generation and macro-generation, energy efficiency, let's go into malaria, HIV/AIDS. The number of challenges that we have, food production, are massive. Don't we have to re-gear our scientific thinking to face up to these? So I don't think the scientific community should feel that it's immune or above the sort of paradigm shift that I'm talking about. I will indicate to you with my last slide what I'm trying to do to match up to that. I've left government to set up a new school in an ancient university, Oxford University. A little bit of an interesting battle, but that's not what I'm going to discuss. The school opened its doors on the 1st of October. We have 32 staff. Our plan is to be 100 staff in a brand new low-carbon building in the middle of Oxford within a few years. The object of the school is to bring together the private sector, governments and academia to find solutions to the problems we're now discussing. And in creating this hub in the middle of a university, we are, of course, creating an interdisciplinary hub, a place where people with disciplinary experts come to work together. So we have appointed 60 associate professors from around the university as associates of the school, and we work closely with all of them. We need, in an interdisciplinary space, to have disciplinary expertise. We will not have any undergraduates in the school. They will go into departments of disciplines. But the University Senate, and I don't know if all my colleagues here from Oxford know this, said that with the formation of this school, my task is to see that every discipline teaches its undergraduates the challenges that we've been talking about here. So in other words, the economists, let me deal with that first, the philosophers, and the engineers and the scientists and the medics will all in their undergraduate careers in time be exposed to lectures which deal with these challenges. So that Oxford tends to produce most of the British prime ministers. We want to see that all future prime ministers will have been exposed to these challenges. And in this space, we bring in fellows from the private sector, fellows from governments around the world, and academia to work together. It's a battle. These are things we have to do. I think we just need to understand the magnitude of the challenge, and then we can get on our way. Thank you.